Hey guys, so from my last video, there wasn't any sound on the part where I explained what double jeopardy is. So I'm gonna try to explain it really quick and then we can jump into the video. So double jeopardy, it's when you, it's defined like when you punish a person for the same crime twice. But in mathematics, it just means that if we have an angle that is in the second quadrant, so this is 0, this is 90 degrees, this is 180, this is 270, and that is 360 degrees. If I have an angle spinning here like this, and then I'm talking about this angle right here, double jeopardy is that when I put this angle, so let's say this is angle A, double jeopardy is when I take another angle, maybe angle phi, and I still treat angle phi as a angle in the second quadrant. So let's say this is -3, this is 4, and that is 5. If I take this into consideration, so if I have something like determine cos A, this would equal to, from what I see, is that phi plus A equal to 180 degrees. So let me just write that properly. This is because it's a straight line. So therefore phi would be 180 minus theta, which now cos A would be cos of 180 minus phi, and cos of 180 minus phi would be minus cos phi. Double jeopardy means that since I've minus 180 from this, from A, so sorry for that, from A, I reverse the angle 180 degrees to the other side, so the angle will now exist in the first quadrant. So like this. Now if I don't do that, I will jeopardize the angle twice. So I would say angle A is in the third quadrant, and still angle phi is in the third quadrant, and this will make the equation minus cos equal to minus 3 over 4. But this minus 3 over 4 cos is negative in the second, but we've already accounted for that in the 180. So that's kind of the thing that I was explaining with double jeopardy, is that once you determine this, you then are sort of moving the angle into the first quadrant, and all the sides are positive because you kind of took away that angle from the second quadrant. You minus 180 to get it back into the first quadrant, making all the sides positive. That's the thing, the philosophy thing I was trying to explain about double jeopardy, being able to not jeopardize the angle twice. So yeah, hope that makes sense. So let's just jump into the video. So the first question we're gonna do is this. So this is proving similarity. So similarity, proportional triangle theorem, or similarity theorem, is that if two triangles are similar, then their sides are going to be proportional. thus this is it. And it's really easy to explain. We just have to prove that triangle RAB is similar to triangle RST. And how do we prove that? So similar triangles go with either you prove angle, that all three angles are equal, or you can prove side, angle, or so this goes for similar triangles and concurrent triangles. Concurrent triangles means that it's same, and similar triangles means that it is, of course, similar. So so side, I think that's the only two, but with concurrent triangles you can do it angle, but concurrent triangles usually you need to prove that they're exact same. So the best way to do it is to have side to prove concurrency, and angle is probably the best to prove similarity. But yeah, I think anything that involves sides could go to concurrency. However, when they're concurrent, it just means that everything is equal. So if I have two triangles like that, I have A, B, C, and I have another triangle like this, and S, T, U. If side AB is equals to side TU, this side equals to that side, and this side equals to that side, that means these two triangles are concurrent and all the angles match up. So yeah, so let's just get into it. So to prove that this triangle is similar, we have that AB is parallel to ST. So in the diagram, RST is drawn, then AB intersects RS and RT, and A and B respectively, and AB is parallel to, so these are parallel. And what that is telling me is that this angle equals to that angle this angle equals to that angle, and this angle equals to that angle. So jumping in, we're gonna have angle R, and then we're gonna say angle R is common, right? And we're gonna say angle R A B equals to angle R S T, and the reason for this is corresponding angles. Same with angle R B A equals to angle R T S, and this is also corresponding angles. Therefore, therefore triangle RAB is similar to triangle RST. And using proportionality, so using basic proportionality, RA, which is this, would be over RS or AS. So if we have this side over that side, it would equal to something like this side over that side, or this side over that side. The ratio will be same. Also, there's a midpoint theory you can use there, but over AS does equal to RB over BT. Please tell me in the comments if you prefer when you actually draw heights like these and then prove it that way. But this is my favorite way to prove because it's very simple. It's just you prove that they're similar and thus are proportional. So yeah, this says proof with reason OR over WS equals to half. So let's just start with the question first. In the diagram, O is the center of the circle. So this means that PW is the diameter. Is the diameter, right? So if this is the diameter, we know that this angle right here is 90 degrees, and that is an angle subtended by a diameter. And also, since this is the center, this line right here is a line from the center, so it's kind of like a radius. If I extend it to like here, it's like a radius, so that means, and since it's halved here, this angle, this side and this side are equal, and it's angle subtended by radius, chord subtended by radius, I'm so sorry. So yeah, so we have a theorem. So I think yeah, so you have that triangle PWS, or triangle PWS is drawn with PWS on a circle. OR is perpendicular to PS, so that PRS is produced to T. So produced just means that they made the straight line until it reaches T. SW and OT intersected V, so we have this intersecting at V, and OV over OT is 1 over 4. So that just means that if this was X, this was X, this would be 3X right there. So 3X. So they say prove with reason why OR over WS would be 1 over 2. So OR over WS will be 1 over 2. So prove that this side here equals to twice the side. And pretty lucky here because things are making sense nicely. So I'm gonna focus on the two triangles, and we're gonna use similar sides. So we know that PR equals to RS, and then is chord subtended by radius at 90 degrees. So that is equal, or if these are equal, then that, so you'd say like chord equal as something 90 degrees kind of theory. It works in both ways. And then what do we have also? We have, so I kind of want to prove though that those two triangles are similar, but I kind of also want to write down my information. So OP is equals to OW, and then this is Radi. So now proving those triangles would be easy. So now you just want to prove that this triangle, let me just decrease the opacity of this triangle right here is similar to this triangle right there. And if you see where this is going, we're gonna have the situation we had last time, which is angle, angle, angle. So this angle, that angle, that angle, and these two angles right here. So this one and this one. So before we get there, we want to talk about OR and WS. In midpoint theory and circle theory, if you have a circle, right, and you have a chord, and this chord is then cut in the middle, if you make two triangles that are on so okay, my chord is definitely not on the middle, but if this is equal to that, this line here is parallel to that line, it's called midpoint theory. Only if this is true, and we know that this is true, we wrote it down, so it's only true when that is the diameter. So we're gonna say, okay, OR is parallel to WS, and it's really nice because you can see that these two corresponding angles are equal, and we say midpoint theorem. Oh, maths always go like, it's theorem, not theory. But yeah. So, what we're gonna do, yeah. So, that is it there. So, now continuing with oh, it's a different eraser. Continuing. Now knowing that this line right here is parallel to that line and use a different color, we could now go in and do our proof. So firstly we're gonna say angle P, sorry, I always write with black, angle P is common. The reason I use black is like the things I write in black are either given or stuff I would write in an answer sheet. So black is like the important. P is common. Angle PRS, so angle PRS is equal to, okay, we didn't state that angle, so before we do this we need to state why the other angle is 90 degrees. Angle PSW, we can use corresponding angles, but I think using that shows also a level of understanding with Euclidean geometry. So you have that is 90 degrees, and you say angle subtended, oh my god, I wrote the whole subtended by diameter. So yeah, and now we have that angle PSW equals to angle PRO, right, which equals to 90 degrees. And what do we also have? So we have the first angle where angle P is common, right? That, and then we have angle POR. So angle POR equals to angle P, well, just can say angle W because it doesn't have very like this has, you wouldn't know which one you're preferring to because S has two sides such as W, such as other angles. And then the reason is corresponding angles. So even here you can write corresponding angles, but yeah, we just have that. Therefore, triangle PRO is similar to triangle PSW. Right? So now that we have determined similarity, what we can use like proportionality in our advantage. And now you can say, okay, angle, not angle, OR over WS equals to PR over PS, and this is proportionality. I don't think you need to write the whole thing. So OR over WS equals to PR would be 1 over 2. The reason is that if I do this as W, and I'm only doing this because of and this is W, then you have W over 2W, and you have that 1 over 2. But if you're gonna use the W thing, you probably would have to write it down. So yeah, and then angle question 10.2.2. I am really bad at YouTube, aren't I? Says if calculate PT, so this whole, if ST equals to 15 units. So we're saying that they're saying that if this side equals to 15 units. So I don't know if you guys just want to jump into it, but let's jump into it. This is a not nice screen. So I would actually have, let me lower opacity and let me use a different color because I think we've already used that color. This angle right here, this triangle right here, and which other triangle? This triangle over here also. So because I don't need PR because I know PR equals to RS, right? So, and then yeah, PR equals to RS. So I don't need that much, but I need this information right here that I'm given. So I know that if I say let's just increase, if OV equals to X, then VT would equal to 3X, and that is given, right? So if now we have to prove similar triangles, so we're gonna say in triangle ORT and triangle SVT. Angle T is common. Right. The second thing we know about these angles is that this angle is 90 degrees right here. This angle is 90 degrees and this angle is 90 degrees. So angle ORS equals to angle VST, which equals to 90 degrees. And we've already stated it in the previous thing. And now, since this is parallel to that, remember these two lines are parallel, this angle right here equals to that angle. So angle ROT, it's fine if we say V or T, so ROT equals to angle SVT, and the reason for that is corresponding angles. So therefore triangle ORT is similar to triangle SVT, right? Okay, then we're going to use proportionality theory, right? We're going to say since we're looking at the bigger picture of this triangle and we have this side, we're going to start with ST. So RS over ST would be equal to OV over VT. So RS over ST equals to OV over VT, and this is proportion, right? So now we know that RS over ST equals to ZX over 3X, which equals to 1 over 3. Therefore RS equals to 3 RS equals to ST, right? So what did we know? We know that PR over RS equals to W's, right? So we can solve for W from this puppy right here. So 3 times W equals to ST, which is 15 units. Therefore W equals to 5 units. PT equals to how many units? This is 3W. So PT would be equal to 5 W's, which is 5 times 5 would equal to 25 units. And you get your 4 marks. That is a lot. But this is very low because the first one you got more marks than the second one. But it is very nice on how you solve it. There are other ways to solve it, but also the reason I get so into detail, especially I encourage you to get into detail, is so that you don't lose marks from not writing things that are important because you chose to write selective things. Like stuff like substituting sometimes is important. So sometimes if you don't write that substitution, or you don't do that 3 times x is 3x, or all those things, you are highly likely to lose marks unnecessarily. So it's best to write everything and to make everything clear for the examiners when you're doing this. So yeah, hopefully this helps, guys. We're gonna finish up last year's paper, and then I am going to do statistics with you. So I will show you how to do statistics, but it's probably not going to help because I'm going to be using a system called a programming language called Mathematica or Wolfram, if you know it's like Wolfram, or I'll be using Octave, one of the two. The reason is I can't get the calculator app on my laptop, so I do have it on my phone, but it would be like I don't know how to screen record my phone and all that. But if if you want more statistic, I will show you how to get the mode mean. But all of this is it's calculator dependent. So literally stats is just being able to put the information correctly so that you don't you don't get the wrong answers when you like ask for it, like median, mode, range, all those things, so it gives you the proper answers. So let me know what you guys think, and thank you so much for watching. Yeah, see you next time. Bye.